Okay. Oops. Here we go. 5.4, trigonometric functions defined in the unit circle. Just two objectives today. We're going to use this unit circle to define trig functions and then evaluate using the unit circle as well. Okay? So that's our two objectives for today. Now, think about something for a moment of what we've done. We were creating trig functions based off acute angles, right? We did everything with acute angles. And then we expanded it, right? We went to other quadrants, and we found trig measurements in those other quadrants by using reference angles, right? So like, sine of 120 degrees, what was that the same thing as sine of 60 degrees? Okay, so we're doing stuff like that. The only thing we didn't really talk about is what happens if sine was 0 or 90 or cosine was 0 and 90 or anything like that. Because you can't draw a triangle that's 0 degrees in it. That doesn't work out. So how do we find those things? So let's take a look. First, what is the unit circle? So definition. A circle with a radius, 1 unit, and centered at the origin is called a unit circle. Okay. Each point on the unit circle satisfies the equation x squared plus y squared equals 1. Okay, so it's just a circle with a radius of 1. Let's draw a picture. Okay. Let's see if I can. That was awful. Let's try that again. That was not good. Actually, you know what? I did this on purpose. Protractor. Not protractor, compass. I had to go into the definition. I couldn't have done that any worse. Okay. That's a great start to a lesson, right? I know, it's not even perfect down there. You know what? We're going with it. We're going with it. It's happening. Okay. We're gonna go with it. Alrighty. So, here's my unit circle. Okay. Any point that's on this circle, the radius is going to be 1. Okay. So, there we go. We're just going to go with it. So, at this point, this is going to be 1, 0. Okay, the point up here is 0, 1. This point would be, that's not good. I'll put it in here. Negative 1, 0. And then down here would be 0, negative 1. Okay. And the reason why those are the points is, again, radius of 1. Okay. Now, if I want to find a point that's on the unit circle, let's say here. I'm not going to go higher because the definition is going to destroy it. So let's say I want to pick that point, and I want to know what its coordinates are. Okay? I want to know what are those coordinates. Well, I can figure it out by drawing a right triangle. Okay? We did this with one of the prior lessons. So if I were just to, draw the radius, then draw up a perpendicular to the x-axis. Okay? I know the radius is 1. Here's an angle. Here's 90. Okay? Now, here's the cool part. So this is my x coordinate. This would be my y coordinate. Well, because that's a 1, if I want to find the x coordinate, I'd use cosine, right? Because that's adjacent. So it'd be cosine of theta equals x over 1. Well, doesn't that just simplify to x? So the x-coordinate on that unit circle is just cosine of the angle, cosine of theta, whatever theta is, which we're not specifying here. So that's the x-coordinate on that unit circle. So what do you think the y-coordinate is going to be? Any thoughts?
0.
Nope.
What? Oh.
So
Oh, then you point on the circle.
sine of theta would be y over 1. So solving for the y-coordinate, it's just going to be sine of theta. Whatever the angle is. I don't know what the angle is, it's just something generic. So if I want to find any point that's on the unit circle, it's just cosine of the angle and sine of that angle. That's it. That's pretty handy. When we did points on just an xy plane, we had to find what? R? Remember how we had to do that first and then come up with the ratios? But inside a unit circle, I don't have to do that. The unit's already 1, so it's just simplifying to x. The x-coordinate is just cosine of theta, and the y-coordinate is just sine of theta. Okay? Now, that's a good thing because here's the deal. I can now figure out angles that I couldn't do in a triangle. So for instance, if I want to look at this angle here, that's 0 degrees, right? So if I take sine of 0 degrees, well, we know sine's the y-coordinate, right? What's the y-coordinate? 0. Couldn't do that in a triangle because you can't have a 0-degree angle. So the unit circle is allowing us to find these extra values. If I do cosine of 0 degrees, cosine's the x-coordinate, it's going to be a 1. Okay? Does that make sense? So if I pick this point, that's what, 90 degrees is where we went? We went 90. So if I did sine of 90 degrees, well, sine's the y-coordinate, right? Which is 1. Again, we don't pick 90 degrees in a triangle to evaluate trig functions, but with the unit circle, we can figure that part out. So cosine of 90 degrees would be 0. It's the x-coordinate. Okay? So I'm not going to go through every single one, but do we understand what we're doing so far? So this is key. If I want to find any point on the unit circle, okay, whatever the x-coordinate is, it's just cosine of that angle it makes. And then the y-coordinate is the sine of that makes. Okay? Which, that's awesome. That really helps us out with calculations, and it helps us to find those other angle measurements that we couldn't find with a triangle. Let's try an example. Suppose we have point P, which is 4 over 6, negative 2 square roots of 5 over 6, on the unit circle. Evaluate the 6 trig functions. Okay. So I'm going to give you a point, and we're going to find what sine, cosine, tangent would be at that point, along with secant, cosecant, and cotangent. If you want to draw a picture, it's never a bad idea. It's good to organize our thoughts. So I'll draw a picture over here. So 4 over 6, that's a positive x, and then the y is negative, so that would be 4th quadrant. We okay with that? Yep, so it's somewhere down here, this point, okay? So, why not? I'll label it. So there's our point. Okay. So now we just got to find the 6 trig functions that go with that point. Okay. Well, from over here, I know cosine is the x-coordinate. So my x-coordinate is 4 over 6. So cosine of theta is going to be 4 over 6. You can reduce, and you should reduce always. So we'll change that to 2 over 3. Okay. Next, sine of theta. So sine of theta on that unit circle is going to be the y-coordinate. So that's going to be negative 2 square root of 5 over 6. Tangent. So let's think about tangent for a moment. So tangent, if you remember, was what? Sine over cosine, right? That's what we talked about. So sine's the y-coordinate, cosine's the x-coordinate. So I'm just going to put these two together as a fraction. So negative 2 squared root of 5 over 6 divided by 4 over 6. So we're going to have a little bit of reducing there to simplify. Okay, the 6's we're going to end up reducing. So we get negative 2 squared root of 5 over 4. And then I could reduce the values that are outside of that root. So we get negative square root of 5 over 2. Okay. So far, so good. All right, we got the other ones to go. So let's look at secant of theta. Okay. So if you remember, secant is just the reciprocal of cosine, right? It's 1 over cosine. So it's going to be 1 over, and we know cosine's 2/3, so 1 over 2/3, which becomes 3 over 2. Okay, next we can do cosecant. Okay. So cosecant of theta is 1 over sine of theta, so 1 over this guy. So yeah, we're going to have to do a little bit of simplifying there. That's a 5. That's a bad 5. There we go. So this is going to be 6 over negative 2 times the square root of 5. So now we'll rationalize it. So we'll multiply top and bottom by square root of 5. So this would be 6 square roots of 5. On the bottom would be a negative 10. I'm just skipping the step where I'm rationalizing. Again, I'm just multiplying top and bottom by square root of 5 to get to that point. And then we reduce what's on the outside. So this would be 3, and we can put the negative on top now. So square root of 3 over 5 over 5. And then last one's cotangent. Okay, so cotangent, we're going to put it here. I'm going to try and keep it on the same board. So it's 1 over this guy. 1 over negative square root of 5 or 6, or over 2. So simplifying it, that's going to flip it. Okay. And we do have to rationalize, so I'll multiply top and bottom by square root of 5. Again, I'm not going to show that step, I'm just going to do that in my head. So it'd be negative 2 square root of 5 over 5. Okay. So at that point on the unit circle, okay, using the angle that is created with it, those are the 6 functions, the 6 trig functions and what they are at that point. Okay? Alrighty. Questions? Yes?
So when we use 1 for the hypotenuse and all the stuff before this, is that because of unit circles?
Yes, that's why we were doing it.
Okay.
Because 1, it's a lot easier for the calculation portion. And we're now, which you'll see in a little moment, we're going to go back to some of the special right triangles where I did that, and we're going to put them on here as well. Okay? All right. Now, this is using the angle, right? But there's something I want to talk about next. What about this arc that's created from here to here? So that random point that I picked, is there something going on with the arc and with this angle? Is there some connection, some relationship? Okay? Let's talk about that next. So let's start evaluating trig functions using the unit circle. Okay. So let point P be some point on the unit circle. Associated with a real number, we're going to call it t. Okay, so a real number that is going to be associated with that point is real number t. Okay, and in this case, we do want t to be positive. I'll tell you what happens if t is negative, but for right now, let's keep it positive. Let our angle be positive, and it's going to be the central angle in standard position. Measured in radians. With the terminal side through P, point P, and the arc length T. Okay? Now, I'm going to draw the picture that represents this, but I want to have the picture and the words together. Okay? So let me draw the picture underneath it. Okay. Can I do it? That's a little better, huh? Maybe I should just stick drawing the circles freehand. I am going to use the compass when I do the final unit circle, because I probably need a whole whiteboard for that, just so everyone can see the numbers. But that's okay. That's fine for right now. All right. So let's say right here, here's my point P, so x, y. Okay, so there it is. Here is my angle, theta. So the angle that goes all the way to that point. Let me use a different color. There's purple. Well, I don't know. Maybe red would look better. I don't know if people can see purple and blue next to each other like that, so we'll do red. So this red is the arc it's talking about. So this is our arc T. And again, the arc's positive, okay? Right there. Okay. Now, here's the deal, okay? We know that an arc length can be found by taking the radius multiplied by your angle, right? We talked about that, I think, one of the very first lessons. So in this situation, when we talk about unit circle, we don't like to use S. We want to be a little bit more specific. So typically, they swap S out with T. So T is going to be my arc length when talking about unit circle. Now, here's the cool part. What's the radius of the unit circle? 1. And then we have our angle. Whatever our angle is that's made, get to that point. Well, if I simplify this, I get that the arc length is equal to the angle. They're one and the same. So if this, let's say it was, I don't know, trying to pick a number, let's say 2 pi over 3. Let's say the angle measures 2 pi over 3. Well, guess what the arc measurement is? 2 pi over 3. They're one and the same. And that's because the radius is 1. Okay? So when they're talking about arc lengths in this section, we're not looking at S anymore. We're just going to replace it with T. Okay? Just to let you know that we're using the unit circle with that guy. So let me just go ahead and write this. Yeah, I think we're okay. Let me write it over here. Because I don't think I'm going to have space over there. So, which is unfortunate. I need like one more whiteboard over there. Is what it is. So, there is a one-to-one correspondence between our real number t and the radian measure theta. Okay. So if they tell you that the arc length is pi over 4, then the angle that's made with that arc length is also pi over 4. So we don't have to figure that part out. We actually know what it is ahead of time. Okay. So here's what we can do. So if theta is equal to t radians, then I can redefine my unit circle just a little bit with the coordinates. So sine of that arc is the same thing as sine of the angle. Okay? Let me go ahead and write the other one. So cosine of the arc is the same thing as cosine of its angle. Tangent, cosecant, secant, and cotangent. Okay, so they are equivalent to each other. Okay, any questions so far on what we did? So now, with the information I've given us, let's summarize it, and then let's come up with the whole unit circle, okay? So let's do that next. So underneath here, just to summarize, starting from what I said at the beginning till now, okay? So let P be some point be associated with a real number t measured along the circumference of the unit circle from point 1, 0. Yeah, I'm not going to squish that on the bottom. I'll continue on this whiteboard. Okay. So let's just say the point's right here. And different color. Where's red? Where's red? And there's my arc T. So now we can say the following, that if I want to find sine of the arc, it's the same thing as the y coordinate of that point. If I want to find the cosine of that arc, it's the same thing as the x coordinate. Tangent would be y over x. Okay? So again, because we now know that the angle that's made is the same as the arc length, now we can kind of define what the unit circle is. So the arc length of this guy is the same as the angle that it makes with it. So now we're defining our 6 trig functions with it. Okay? So we know cosecant of the arc is the same thing as 1 over this guy, so 1 over the y coordinate. Secant would be 1 over the x coordinate, and then cotangent is just the reciprocal of tangent there. Okay? So this right here is how we're defining our unit circle. Okay. Awesome. So we laid a lot of groundwork here, made some good observations. Now, if you remember from a prior lesson, we did special angle relationships. We did 30 degrees, 45 degrees, and 60 degrees, right? Those, the 30, 60, 90 triangle, 45, 45, 90 triangle. So what I'm going to do is put those special angles in here and see what points correspond to those special angles, okay? And then once we have this filled out, we're going to fill out the other quadrants as well and see possibly some behaviors, some observations, and hopefully we can fill out the whole thing without really too much computation work. So let's go back. To our 30, 60, 90, 45, 45, 90 triangles. Okay, so let's go back to those. I'm going to draw them underneath. Now we have a good reference to it. there was a 30, 60, 90 that we derived in the past. Okay. Next one. This was our 45, 45, 90. And then our final one, so let's change it to a 60 this time. It's the same triangle, I'm just flipping where the values are. So 60, 30, and let's see, that would be half, square root of 3 over 2. And that coordinate would be a half, square root of 3 over 2. Okay, so again, we derived these from the past, I'm just rewriting it for us. So again, what I'm gonna do now is put these three into our unit circle, and again, just see what happens here. See if we can come up with a full unit circle with these special angle relationships, okay? There are values besides these in the unit circle. You can have 20 degrees, you can have all these other things. But the reason why we're focusing on these specific angles is because we actually know what the exact values are, okay? Without using like a calculator or a table or anything like that. I'm going to, because I think it'd be easier if you're in the middle. I'm gonna erase that board. I'm gonna keep this on. I'm gonna erase that board, and then we're gonna start deriving the unit circle here, okay? So you're gonna have to draw a circle in your notes. I would recommend, not a small circle, trying to make it, maybe make a full page, just so you have enough space. Might make it a little easier. It's up to you. I promise I'm not drunk. Is that a law? You can't do math while drunk? That'd be interesting. Teach while drunk. That's true. All right, try one more time. The suction cup on this is not the greatest. Place. Okay. I'm gonna take it. That's good enough. All right, so we know this point's 1, 0. This point is 0, 1. Over here is negative 1, 0. And then down here is 0, negative 1. Okay. It's not bad. Let me put the radian measurement. So here it's 0 degrees, or I'm sorry, just 0 radians. This is 90. What was 90 as radians? You remember?
2.
Pi over 2. Yep. So this is pi over 2, or 90 degrees. Over here, 180 was what again? Pi. This is 270, which was what as radians? 3 pi over 2. And then back up to here, we're back to 2 pi. Okay. There we go. Okay, so let's fill out the first quadrant with our special angle relationships, okay? All right. So let's start with the 30 degrees. I try my best. That's not that bad, I take it. Okay, so from here to here, we traveled 30 degrees. What is that? I don't know if you remember, what's 30 degrees as a radian measure? Pi over 6, very good. So it's pi over 6. Okay. Now, what point corresponds to that on the unit circle? Well, we have it over here, right? So 30 degrees, that point was square root of 3 over 2.5. So I'm going to put that right here. Square root of 3 over 2 and a half. Okay? So if I asked you, hey, what's cosine of 30? You'd say, oh, that's square root of 3 over 2. I say, hey, what's sine? You say, oh, that's a half. Okay. Next, 45. Well, actually, I tell you what. Let's mess with this one a little bit. Can I make the same thing over here? 30 degrees. Yeah, I can, right? I hope so. We're gonna see if I can. Oh man, I really hope this looks nice. If not, I'll fix it in post. I'm liking it. I'm liking it. I can dig it. Okay. So I'm on this side, right? Now, degree-wise, so we start from here, right? Anytime we do angles. So I went all the way over here. So this is 180, and this is like 30 degrees from it. Is that what, 150? Does that make sense? Okay, so this is going to be 150 degrees. Okay. Now, the radian measure, I could do some conversions, but let's think about this. Pi over 6 was 30 degrees, right? If I hit 180, which is pi, isn't that the same thing as 6 pi over 6? Does that make sense? So you want one less than that. So this will be 5 pi over 6. Again, you can get to that by converting, but I'm just kind of using some fractions to understand that. Now, this point is going to be the same as this point, but there's a little change. The signs, right? Does that make sense? So the x-coordinate on this is going to be negative, but the y-coordinate is going to stay the same. So if I were to say, hey, what's cosine of 5 pi over 6? You say, oh, it's negative square root of 3 over 2. Or what's sine of 5 pi over 6? You say, oh, it's a half. Now I could do the same thing, what, underneath it? See, I can draw like 2 more of these angles underneath and kind of get the same result. So let's do that next. So over here, can I, maybe? Yep. Okay, it's looking good. So this is going to be the same measurements of these guys, right? So at this point, it's going to be still square root of 3 over 2 and a half, but I'm in the third quadrant, so these are going to be both negative, right? Okay, so they're both going to be negative. Now let's think about what the angle is to get there. So I start here, full rotation. So I went a full 180, and then I added, what, 30 degrees? Isn't that what I did? 30 degrees here, so that's what, 210? Okay with that? 210 degrees? We doing good? Now, radian measurement. Again, I can convert it, but let's be smart. We know here would be 6 pi over 6, right? So it'll be one more to get the other quadrant. This would be 7 pi over 6. Okay? And then we get the last one. All right, so last one over here. See why I kind of said make like a big circle, because we're writing a lot in here. Okay, so angle-wise, going the whole way around, but 30 degrees less than that, so that's what, 330? So 330 degrees. Radian measure, well, the whole thing's 2 pi, right? And we're doing pi 6 increments. So if I do 12 pi over 6, that reduces to 2 pi, so we want one less than that. So 11 pi over 6 is what that would be. And the points, well, it's the same point as what we started with. But I think just the y value is negative, huh? So if I asked you what's sine of 330 degrees, you would say, oh, that's negative a half, because sine goes with the y coordinate. Okay, any questions on how we got to those ones? So see how we're going to do the 45s and the 60s? Same pattern, right? Okay. let's do the 45s next. Were you able to fit it?
Yeah, we want to.
Here we go, 45s. Okay. All right, so we're gonna look at that middle triangle. So I know the point that goes with it is square root of 2 over 2. Okay, and this is pi over 4, or we know it as 45 degrees. Okay, so let's look down here. We'll do it this way. So I drew just one line to make it easier for myself instead of drawing separately. Probably should have done it at the beginning. But right here, so from here to here is a 45-degree angle, right? Because that's what this is. So if this is at 180, going 45, that'd be what, 225? So that's 225 degrees. The radian measurement, okay, so again, we're going in pi-4th increments. So for it to be pi, it'd be 4 pi over 4. So we're going one more, so it'd be 5 pi over 4. And that point, let me make that a little smaller so I can write it, is going to be negative square root of 2 over 2. Negative square root of 2 over 2. Both negative because in the third quadrant, they're both negative. Okay, let's draw the other side. Okay. Just like that. So are we okay, like getting the rhythm, like how I'm finding those values? We'll just take it through. Okay, so I'm gonna, just to speed things along, I'm gonna go ahead and just write down what these coordinates would be. So this is still gonna be square root of 2 over 2, square root of 2 over 2, except the x's are gonna be negative because you're in quadrant 2. Okay, this is gonna be 135 degrees, which is the same thing as 3 pi over 4. Then down here, okay, again, it's still square root of 2 over 2. Okay, but in that quadrant, we can see that x's are positive, but y's are negative. So at this, we're going to have 315 degrees, which is the same thing as 7 pi over 4. 60 degrees, you ready? Can we fit it? Yes, we can. Okay, here we go. 60 degrees. Hey, think here. There we go. Okay. I mean, this 0, 1 is gonna be in the way. Okay, so this is 60 degrees, which is pi over 3. Now, if you look at the triangle on this side, the coordinates would be a half and square root of 3 over 2. Okay, so there we go. Okay, on the bottom, oh boy. Oh dear. Can we? Even with as large as I made that circle, I'm having a hard time. Okay, so over here, again, just to save some time, this would be 240 degrees, which is the same thing as 4 pi over 3. This would be negative a half, and then negative square root of 3 over 2. It's the same coordinates, but just negatives because we're in the third quadrant. Last one. Here we go. So, I got to move this over here. I will say I'm actually not too upset with how I drew this. No lie, this is the most nervous I've ever been for a lesson because I didn't know if I was going to draw that right. If it was going to fit. Again, a little bit tight of a squeeze, but I was still able to. Okay. Anytime I got to do graphic stuff for lessons, I do get nervous because, again, I want to make sure it works out well. Okay, so for those values, Again, just to save a little bit of time, I'll fill those in. Okay, so this is going to be 120 degrees, which is the same thing as 2 pi over 3. And the coordinates, okay, is going to be negative a half square root of 3 over 2. Okay, it's the same as the 60, it's just I'm changing the signs. And then down here, for the last part, okay, we're going to be at 300 degrees, which is 5 pi over 3. And our points for that one is going to be a half and negative square root of 3 over 2. So there it is. Now again, this is the unit circle with the special angle relationships. Are there values in between that? Yeah, but again, you have a calculator that can work with it. This is at least exact values. Now here's what I would recommend. Okay, as we work through these, this first quadrant and its values, you want to know, okay? And here's why. You can derive the other quadrants with this, with reference angles, okay? So for instance, we know from 30 degrees, pi over 6 is this measurement, okay? If I want to find cosine of 210, it's the same thing as this, but because 210 is in the third quadrant, it's going to be negative, okay? So you're just using those same values over and over again. So that first quadrant is important, okay? Because you can derive the other ones pretty quickly, okay? Now, reference angles. Here's a trick to it. So if you know what the first quadrant values are, if you use reference angles, you can figure out the values for the other ones. So I just want to make a little note for that. So note, to find the reference angles, I'll put or arcs. The reason why I'm putting or arcs there is because we know that the angle and the arc measurement are the same. So if I had 4 pi over 3 and I want to know what sine of that, we'll first find the reference angle. And it's underneath. The reference is just pi over 3. Okay? And if you look at the unit circle that I drew over there, you can see that. So using pi over 3's numbers, you can figure out what sine and cosine is and just change the sign that's necessary. Okay, if you had something like 5 pi over 4, okay, what's the reference? It's pi over 4. Okay? So you use pi over 4's numbers and then just change the signs depending on what quadrant you're in. So if you want to find reference angles, it's actually pretty easy to find. Okay? So we can now see that these trig values are being used outside the means of a triangle. Okay, so we're no longer using a triangle. We can actually just derive it differently. We don't need a triangle to figure out what 90 degrees of cosine would be anymore. Okay? Now, because we're using a unit circle, these trig functions are called circular functions. Okay? Now, why are they called circular? Because if you were to go around the full thing, 360, if you go past 360, these numbers aren't changing. It's still square root of 3 over 2. It's still a half. It's still square root of 2 over 2. So that's why they're called circular, because no matter how many revolutions, no matter how big the degree or arc measurement is, it's still the same values being repeated. So we call those circular functions. Okay, so I just want to do one example with this, and we're done. So sorry, I wanted it to be shorter, but it took a little longer to draw the unit circle. My bad. But you gotta admit, that looks good, right? Mm-hmm. Maybe. It's too much. like I said, that was like all day I was just nervous drawing that because I was like, I really hope it fits. I really hope I don't know. Again, I'm happy with it. So, example. So let's evaluate the 6 trig functions of a real number t. And I don't know where the cap went. Oh, it's right here. All right, so let's say it is 2 pi over 3. Okay. So I want to know what sine, cosine, tangent, all those guys are at 2 pi over 3. Okay. Now, here's the deal. If you have the unit circle, you can look at 2 pi over 3, which is here, and you can find those two values that you're going to use. But again, I want us to kind of rationalize a little bit, work through this logically. So here's how I would do it. Okay. If you didn't have the unit circle handy, I would do this. So we know that 2 pi over 3 is in. Now, if this was 3 pi over 3, that's 180, right? Because it gets you pi. So 2 pi over 3 has to be in the second quadrant. So it's in quadrant 2. I mean, I know we can see off the unit circle, but that's me just kind of showing you the thought process. Okay, so we know that. That's important because that will help us with the signs. Okay, next. The reference arc or angle, doesn't matter because we know they're one and the same, is pi over 3. So what numbers go with pi over 3? Well, if you look at the unit circle, it's a half and square root of 3 over 2. Okay? So if we're in quadrant 2, which one's positive, which one's negative? Yeah, right? So this is gone. That's not gone. That's negative, and that'll be positive, right? Make sense? Because x coordinate's negative in quadrant 2. Okay, so guess what? I'm going to use that to find all my 6 functions. Okay? So let's write it down. So starting with, doesn't matter what you start with. So cosine of 2 pi over 3. So we know that's the x coordinate, so it'll be negative a half. That's it. Okay, next. Sine of 2 pi over 3. Well, it's the y coordinate, square root of 3 over 2. Tangent, pi over 3. Okay, so that's these two as a fraction, right? So it'd be square root of 3 over 2 over negative a half, which reduces to negative square root of 3. I'll put these in boxes so we can see it better. Okay. Questions on how I got those first 3? I'm doing okay? All right, let's keep going. So the reciprocal function would be secant. So that's flipped, so it'd just be negative 2. Cosecant is the reciprocal of this, so it's 2 over square root of 3. Rationalizing it, 2 square roots of 3 over 3. And the last one, cotangent. Oh, I put thetas, my gosh. I even put pi over 3. That's 2 pi over 3. So cotangent of 2 pi over 3 would be 1 over negative square root of 3, which would be negative square root of 3 over 3. So there's our 6 there. So that's me taking the arc measurement or angle, because we know they're one and the same, and finding all the other ones. But what I would do, again, figure out what quadrant you're in, rationalize that, and then what's the reference angle? It's pi over 3. It's whatever the denominator is. And then what is the coordinates for it, and then find if it's positive or negative depending on what quadrant it is in. Okay? So that's all we're going to work on for the next couple days. I just want us to get used to this, used to working with those values and going from there. Questions? Okay, awesome.